Here's number 17. Which of the following transformations appears to represent an isometry? Isometry is same measure. So iso is same and metry is measure, and this is the only one that appears to represent an isometry. So number 18, which types of symmetry does this figure have? And so we're looking at, let's just look at the answers first. Is it reflectional? Well, yes, absolutely. It's you can reflect it about this axis, and you can reflect it about this axis. So it definitely has reflectional, so check that. Does it have rotational? Yes, you could put a point here and spin it around until so this point here, A, spins around to this point. Over, whoops, that's a crappy box. You could spin it around, keep going all the way until A gets down here. So it does have, I drew an upside down A. It does have rotational, so the answer is both rotational and reflectional. I don't even know if that's a word. Okay, next. Oh, this one will be fast. This one says, which of the following shows a triangle and its reflection about the x-axis? Well, let's do each of these. This is not a reflection. This is just a translation. This is a reflection, but C is a reflection, but it's a reflection about the y-axis. No, letter D is a rotation. If this was your first triangle, you see they spun it around to get it to here, and this is the only this is the only answer that's possible. B is a reflection about the x-axis. Oh, okay. Next page. Through with that guy. Maybe we could do the whole thing. Do 2 problems for the price of 1. Oh, good, we did it. Okay, which shows the ordered pair rule for reflection about the y-axis? So the best way to do this is just do a reflection and then see where it goes. So let's take this point 1, 1, and 1. Let's say this is 3, comma 1. So let's take this and reflect it about the y-axis. And this would go to minus 1, 1, and 3, 1 would go to minus 3, 1. So it looks like we just took the x and made the x negative but left the y alone, and that's only this one. See, x becomes negative x and y stays the same. We should always do one more point because there could be something strange going on. So let's take this point. No, let's take this point 1, comma 3, and it would go over to here minus 1, comma 3, and so it's a very just connect the dots, and you can see that that's a reflection about the y-axis. Number 21, the transformation xy goes to minus x minus y is applied to this figure right here. I don't know why that's not really much of a figure, but which graph depicts the image of the figure under this transformation? So the easiest way to do this is just see these points. This is this point right here is 1, comma 4. And that would go to minus 1, minus 4. So let's see if this oh well, yeah, let's just put it up here. Minus 1, minus 4, so it would go right here. So if this was this point A, it would go to this point A. And what about this point right here? Let's call this B. This is 4, 0. Where would that go? Well, if we ran it through this translation right here, it would go to -4, 0, right? Because the x becomes negative x and y becomes negative y, but 0, -0 is just 0, so it would go right over to here. So now we're looking for, okay, so that's, let's see, that's our new B, and this was our B before. So whatever we're looking for better look like this. It better be in quadrant 3. And this is it right here. That's the only one in quadrant 3. This is in quadrant 1. This is in quadrant 4. That's in quadrant 2. Alright, next page. Hope you're hanging in there. It's, and remember, if I'm going too fast, you can always back up and replay, or if I'm going way too slow, you can fast forward and junk. So let's get 2 more problems. So find the area of rectangle JKLM. JKLM. Which one was just this one? So we have, it's 90, whoops, 90 by 39 feet. So it's just the base times the height. And 90 times 39 is going to be, well, it's only one. This is definitely going to end in a 0, right? It has to be this one. It has to be A. And if you did the multiplication, you'd find that too. Okay, what's the area of the figure below? Assume all angles are right angles. Okay, so let's make some boxes. Oh, I like see when I scan this, I see 3 feet by 3 feet there. So there's a corner over, there's a box over here that's 3 by 3, 3 by 3, 3 by 3, a 3 by 3 box. So let's just make all of those boxes. So we have 4 times, we have 4 3 by 3 boxes. Okay, well, let's just do that. That's 36. So that's 36 square feet. Now if we take 3 out of here and 3 out of here, and we know this is a total of 10 feet, then that leaves us 4 feet right here. And if this distance from here to here is 13, we have to add these 3 feet distances here also, so this total distance right here is 13 plus 6, which is 19, and we only have one of those boxes. So let me just, so we have to add 19 times 4, which is 76. So we add those together. Let's add them together and get green. Our total is 112 square feet. Next.